Saxon Algebra 2, lesson 44. We are solving right triangles, and we're using everything we learned last time about trig functions, which are nothing more than just ratios of the different sides of a triangle, right? Opposite, hypotenuse, and adjacent, and we just mix them up in different combos. We compare two sides at a time, and we gave each of those ratios a name, sine, cosine, and tangent. Now we're going to use those nifty little devices to solve some right triangles. So here is the first example. John has given us this triangle. Notice that there's three angles and there's three sides, right? That makes sense. And we know that the way trig functions work is that they relate one angle to two sides, right? And we'll talk about that more as we go. That's probably too theoretical to make any sense to you just yet. But in this, we see we have to find one angle and then we have to find two of the sides. The rule of thumb I recommend is that if you don't have any better ideas, just go in alphabetical order. So let's start with the B. B is an angle. And we look at the other angles and we go, well, wait a minute. They have to add up to 180, right? So if we know the other two, and John didn't tell us that 90 degrees, but we know if it's got that little mark, then it means 90 degrees. So B is going to be equal to 180, the total, minus this one and minus that one. All right, so like so. So let's see. 180 minus, it's 114, right? So B is going to equal 66? Yes. Now, we didn't use any trig to find that out. We used some really basic old school geometry that tells us that they add up to 180. So far so good. Let's keep going alphabetical now. And next up would be H. What can we do to resolve H? We know the size of the angle, and we know, let's see, if we're standing here, this would be the adjacent side, right? And sometimes it helps to write these. This would be the opposite side, and this would be the hypotenuse. What we can do is we can say that the cosine, and I'll tell you why I picked that one in just a minute. The cosine of 24 degrees, and let's just review these. Sine, cosine, tangent. Oscar had a hold over Arthur. Poor little Arthur. He's shaking in his boots and Oscar's just choking him mercilessly. Okay, we know that we have the adjacent side and we're trying to solve for the hypotenuse. We know the size of the angle. So we can take this information. No, we want this information because we have the adjacent side, not the opposite side. We don't know the opposite side. So let's leave that for later. We'll figure that out. But we know that the cosine, which relates the adjacent to the hypotenuse, is going to be equal to 9.5 over h. This is the adjacent side. This is the hypotenuse. Cosine is the one that relates adjacent to hypotenuse. Yay! Okay, that's going to work out just plain fine. So now we have to do a little bit of algebra to get this h by itself. So let's cross multiply and we'll get h times the cosine of 24 degrees equals 9.5, right? We'll put the h first, and after it would be awkward. And then we'll divide both sides by the cosine of 24. All right, now that's gone. H equals 9.5 over, now we need to use our calculators to find the cosine of 24 degrees. We know the degrees, And we want the decimal number that goes here. And for that, we use the regular trig function buttons. So you'll take 24, and then you'll push the button that says cosine. So we'll enter this, and then we'll enter this. No -1, just the plain cosine button. And what we'll get is 0.91. And then our final step is just to do this division, and what we'll get is h equals 10.44. Make sure you can slap the buttons around and get that number to come out for you the right way. Again, if you have any problems, you can talk to your sister or a friend that might know how to do this. Do a little Googling and see if you can find a tutorial. You can ask me or just play with the buttons until you get it right. All right, so now we have figured out this. We know this number, and we figured this out, didn't we? So now the last thing we need to do is figure this one out. Now, we have a couple options for how we do that. One thing we could do, but we're not going to because that would be too easy, is we could use Pythagorean Theorem, right? This squared plus y squared, we'd leave that just the variable, equals the hypotenuse we figured out, it's 10.44. So we could square them all and use Pythagorean to solve. But I don't want to do that because it's an opportunity for us to use another one of our trig functions. So I would like to do that. What I would like to do is say, okay, if we know the angle and we know the adjacent, let's pretend we don't know the hypotenuse, and we want this one, we could use tangent, couldn't we? We'd say the tangent of 24 degrees equals y over 9.5, opposite over adjacent. So I'm going to write that at the top of the next page. The tangent of 24 degrees equals y over 9.5. That's the length of the adjacent side. All right. Now this one is a lot easier to run the numbers around. We're going to cross multiply again. We'll have 9.5 times the tangent of 24 degrees. I'm going to make that decimal brighter. Equals y. Now we can enter the buttons like this. Enter 24. Then hit tangent. You'll get a decimal number, multiply it by 9.5. All right, and the answer that we should get is that y equals, all of this with these numbers should equal 4.23. And so if we take this number back, that means that this number here is 4.23. Now let's look at the lengths of the sides that we came up with and see if they make sense. We said that this leg is 9.5, this leg is 4.23, and this one's 10.44. Does that seem reasonable? I think so. Makes sense to me. So, I mean, it's one of them's not 500. Right? One of them's not -6. These numbers all seem fairly reasonable guesses for the lengths of those sides. So it passes our reasonableness test. Yay, us. All right, that is one thing. What we're doing here, solving right triangles, this is something that trig functions are very good for. All right, let's dive into another. 44.2. Find the missing parts of the triangle. Okay, here we go. And I'm copying it exactly the way John has it. 14, X, and M. Now, as we're doing this, we can immediately start to think, okay, we know the angle and we know the hypotenuse, right? This is the hypotenuse. That means we could use sine to solve for this one because this is the opposite side, or we can use cosine to solve for this one because this is the adjacent side. So we're looking for the function that matches with the information we have. We've got the hypotenuse, we can use that in both of them, and we've got the angle. So this is going to be, we can see it starting to come together. We've got b degrees in here, and we know, oh, that's going to be easy to find. That's just a little addition and subtraction. So we are going to take a look at this, and again, our hypotenuse is 14, so we want these to be reasonable, right? If one of these legs was 26, I would think something went awry because our hypotenuse is 14. If one of these sides was 0.71, I'd think something had gone awry. So here, I'm looking for numbers, what, maybe like 6 or 8, something like that? That would seem like reasonable legs for a big hypotenuse like that. All right, so let's start with B. This is what we did last time. We know that these have to add up to 180, and we'll subtract out the ones that we know, right? We'll subtract out the other two. That comes together to be 125. So B equals, what is that? 55. I'm just doing the subtraction in my head. If you prefer to write it out, that's fine. But I was just eyeballing that. I know that the number that I add here, they're not going to add up to 8. The tens place number shouldn't add to 8. They should only add to 7 because I'll carry the 1 from that. That's what my brain was thinking about. Okay, so now we want to find, let's just keep going alphabetical. We'll do M. M equals the adjacent side. And let's write our functions again so we know which sides go with which function. Oscar had a hold over Arthur. Oh, he's still choking him. It's such a sad scene. If you have younger siblings in the house, you may have to shield their eyes from your math problems so they don't get traumatized. All right, so we're going to do M first. That's the adjacent side. So we'll say the cosine of 35 degrees equals, we'll use M because that's the letter we're using, but it's the adjacent side, so that matches, over the hypotenuse, which is 14. And then we will cross multiply, and it's going to happen a lot, you guys, where we have the angle here, and then we have the unknown in the numerator and the known hypotenuse down below. We're going to get this pattern a lot. And what you'll see is that you can just kind of automatically bring this up, right? We're cross multiplying and it all takes care of itself. And algebraically, we can sort of shortcut it by saying, well, let's just multiply by 14. So from this, you can immediately go into your calculator. Enter 35, hit cosine, and then times 14, and you will get M equals 11.47. That is the length of side M. Does it make sense to you that this would be 11.5 if this is 14? Yeah, I can believe that. Can you? Makes sense. Seems reasonable. Okay, and then we'll do X over here. Here, we're working with the opposite side, so we'll want to use the sine function. We'll say the sine, again, of 35 degrees equals the opposite, we're calling it X, over the hypotenuse, which is 14. So that's how we can use these functions to set up little equations, easily solvable, as long as we have a calculator, for the length of that side. It's so cool. It's so like fun that we can resolve these mysteries. I personally think it's great. So again, we're going to cross multiply these. The X will be isolated because it's being multiplied by a 1 down here, right? So when we cross multiply, what we're really saying is bring this 14 up and put it there. Then we multiply backwards, if that helps you think of it. We enter 35, then we hit the sine function, and then we say times 14. All right, and what we will get is that X equals 8.03. And again, that makes sense. If this side's 14 and that's 11, then this one being 8, yeah, that makes sense. Especially if you look at the picture in the book, where I think this side is a little long on mine, and it should be a little bit closer to that side. John's drawings are a little closer to perfect than mine are, but even with mine, that seems reasonable. So we accept these answers. Anytime we use a calculator, we want to keep our brains turned on. And again, that's why I don't like to use calculators, is because so often we just fall into, oh look, we have a calculator, push buttons, that we stop thinking. Okay, so that's the end of problem 44.2, right? Did we find all of them? We found B is 55, we found M is this, and we found X is that. Yay! And now we have one more. Example 44.3. Find the missing parts of the triangle. Oh, John is like a broken record. So needy, isn't he? Okay, this is A degrees. This is B degrees. Here's a right angle. Okay, so we copy it. Maybe you noticed it. I did, but I'm always looking for where John's going to throw his next trick. We still have the B up here, right? Oh yeah, we'll just subtract 180 and the other pieces, but then we go, oh wait, he didn't give us 2 of these. That means we can't just subtract from 180 to get the answer to this angle. That means we're going to have to use another trick. We do know this is 90 degrees, that's for sure. So we know those two have to add up to 90, but knowing which one they are, we don't know. So we're going to have to think of another way. So I take my own advice and I look to where there are other numbers, and I think of how I can use numbers to help me find, I'm working on A, I want to do that first. And I see we've got a number right here. And if I stand in this corner, then this side would be the adjacent, right? And this, no matter where I'm standing, this is the hypotenuse. Okay. Let's take a look at our functions again. Sine, cosine, tangent. You know, math teachers throw that word around a lot, functions. Functions are just a certain kind of problem. They're a certain kind of operation, right? You can have linear functions. Those are problems about lines. You can have quadratic functions. Those are problems about quadratics. You can have exponential functions. We haven't done too many of those yet, but those are problems where we're focusing on the exponents. These are called trig functions because they're problems that focus on trigonometry. So don't let that word function scare you. It really just means it's a certain type of problem. And it's a little more specific than that. There are certain kinds of problems that qualify as functions and other problems that are interesting but aren't technically functions. But when we say, oh, let's talk about linear functions, what I'm really saying is let's just talk about the linear type of problems that we've been studying. Don't let that word function scare you, especially at the college level. They like to toss it around a lot. You already know all the math underneath. It's just that word that can feel strange. Guess what? Oscar had a hold over Arthur. Have you heard the news? It's true. Okay, so here's my little list of ideas of what I might be able to use to solve this. And what I see is that I've got the numbers for the adjacent and the hypotenuse. Adjacent and hypotenuse. So I can say that the cosine of A degrees, that's my variable, is going to equal 6 over 7 because that's adjacent over hypotenuse, right? Okay, I can turn 6 over 7 into a decimal number. So I can rewrite this problem as the cosine of A equals 0.86, right? I just divide 6 divided by 7 gives me 8.6. Now I'm ready to go to my calculator. I'm going to need to use the inverse function because I know the decimal, but I don't know the degrees. So I'm going to enter 0.86, that's the decimal number, and then I'm going to hit the second key, and then I'm going to hit cosine of -1. And that will tell me that the answer, the size of the angle that has a cosine of 0.86 is 31.00 degrees. A lot of times we get wonky decimals, so that's kind of exciting. All right, so what I did was I used the numbers I had and I figured out which trig function they would help me with, and I used this information about the sides to find the decimal, and then I used the calculator to go from the decimal to the degrees. Oh my gosh, that was kind of fun, wasn't it? So now we've got A taken care of. And now we can easily find B, right? Now we can use our 180 trick because B is going to equal 180 minus the 90 and then minus the 31. So our B equals, let's see, this much takes us down to 90, and then we subtract 31 and it's going to be what, 59 degrees? Let me see if John agrees with us. 31, John rounds this to a 1/100. Sometimes John's rounding gets a little screwy. I'll talk more about that as we go. So he has this as 31.01 and he has this as 58.99. I stand by our numbers. If we're off by 1/100th, it's okay. Now what we're going to do is we're going to go back and try to find a value for x. Now, we could use tangent. We did that before, right? Now that we know this angle sign, we could say that the tangent of 31 degrees equals x over 6. But this time, just for fun, let's use Pythagorean, all right? We've used all of the functions at least once now. So let's solve for x using Pythagorean. So we would say that x squared plus 6 squared equals 7 squared. Right? This is a squared, and this is b squared, and this is c squared. All right, so we'll run out these numbers. This is 36, and this is 49. And then we will subtract 36, and we'll get that x squared equals 13, and then we'll take the square root. And we don't have to worry about the negative square root because I'm pretty sure that this length is not a negative number, aren't you? It's a fun thing. We've talked about it in geometry. We can often discard negative roots because they're illogical, given that we're dealing with a shape. And we can do that in this case. We'd say that x equals the square root of 13. That's correct. Now let me just say one more thing about this answer. When I see this answer written this way, I know Pythagorean Theorem was used to solve it. In here we're going to use Pythag to solve for x. And up here, what I want to do in this box is I want to use tangent to solve for x. I want to show you how it would look slightly different. So in this one, we know that our angle is 31. So we would say that the tangent of 31 degrees equals opposite x over the adjacent, which is 6, right? And then we would cross multiply. We would take this and we would bring it up here and we would enter 31 and then we would hit tangent and then we would multiply by 6. And the answer we would get for x here is 3.61, and that's the correct answer. Now, did we get the same answer for both parts? That's our question. If you take 13 and hit the square root button on your calculator, you should get 3.61. If you use a trig function, your answer will come out in a decimal. If you use Pythagorean Theorem, you don't need a calculator, but your answer will come out in a radical. All right? These two numbers are the same. Check and make sure, right? Find the square root of 13 and see if it's not 3.61. But if it makes a difference to you which form your answer is in, then that might help you decide which method to use. As far as I'm concerned, I am perfectly happy with either one. And it doesn't matter to me, just whichever one feels good in your brain. All right, so there's two ways to solve for that third side. All right, is there one more? No, there's not. Oh, we're done. That was a rigorous lesson, you guys. That was a lot of work, a lot of similar but different kinds of steps. We will be working this kind of problem and we'll be building on this and we'll be doing a ton of this. So we're just starting to dip our toe in the water. But that is the end of lesson 44. Oh, I forgot to cross off last time. That means we are done with week 12. Well, you still have to do your homework. Sorry. And it's time for a review problem again. We have one more week of new lessons before we prepare for the midterm. Students that work with me directly, it'll be the same process as always, right? We'll prepare, we'll take the midterm. I'll probably just bring it to your house again. And you'll take the test and then we'll be done for the break. Students who have found me on YouTube and may or may not be working with another teacher, you may have your own testing plan. That's, of course, fine with me, whatever works for you. But if you're homeschooling and you don't have a test plan, if you want to email me, I will send you the PDF of the tests that I write for my students, my other students. It goes up through lesson 48. It's 10 problems long. It's problems directly from the homework, blah, blah, blah. If you're interested in finding out more about that test so that you can get some testing into your file for your homeschooling work, reach out to me. My email address is in my About page on YouTube. You can also search me and find me on Facebook. Send your mom over. You can find me on Instagram. I'm pretty much anywhere. Twitter. So if you want to talk to me more about the possibility of taking the same test that my I don't know what to call my students that I see face-to-face. I guess my face-to-face students, except I don't see them face-to-face. So anyway, my other students, let me know and we can work that out. Okay, I'm done talking. Thank you, bye.